KSRM faculty lecturer is Dr. S.L. Pratap Reddy garu, who is going to discuss section to wireless communication. Sir is from the Department of Electronics and Communication Engineering, and he is an associate professor. Sir, we request you.
Hello, sir.
To
Sir, voice
start the
audible, sir?
session, sir.
Okay. Voice audible, and
Yes,
Sir, we request you to. Yes, sir. Yes.
PPT is visible, sir?
And sir,
Right.
please go to.
Sir, అది ప్రాబ్లం ఉంది సార్. చేశాను, చాలాసార్లు ట్రై చేశాను, రావట్లా.
Okay, sir. Please begin the session, sir.
Okay, right.
Present.
Sir.
Present entire
Hello.
screen this call, sir.
Entire screen problem.
Present now an option click.
Sir,
Okay,
Arun,
okay,
sir.
sir.
Arun sir చేశారు, తనకేదో ప్రాబ్లం ఉంది.
సిస్టమ్
స్టార్ట్
రావట్లేదు సార్ ఇక్కడ.
ఓకే, నో ప్రాబ్లం.
చూడండి సార్, ట్రై చేశాను. ఓకేనా సార్?
Sir, please start the session, sir.
Okay. Right. So, good evening to all. Today, I'll discuss about the introduction to wireless communication. So, first of all, what is wireless communication? The word wireless is defined having no wires in networking terminology. Wireless is the term used to describe any computer networks where there is no physically wired connection between sender and receiver, but rather than the network is connected by radio waves or microwaves to maintain communications. Wireless networking utilizes specific equipment such as NIC and routers in place of wires. Generally, you can consider to the copper or optical fibers. So, today the main content of our one. Introduction to wireless communication, advantage, disadvantage, and applications of wireless communication, evolutions of cellular mobile communications like first generation, second generation, third generation, fourth generation, fifth generation, sixth generation, seventh generation, and also fifth generation technology, architecture and design. So, the first generation introduced in 1980s. The example of first generation AMPS system. This stands for AMPS, Advanced Mobile Phone Systems. The first generation upload the frequency from 824 to 845 megahertz, download 869 to 894 megahertz. The bandwidth of first generation 30 kilohertz. Generally, the first generation we are using to the modulation is frequency modulation. The multiple axis of first generation is FDMA, frequency division multiple axis. The data rate of first generation 2.5 kbps. The main application of first generation is it supports only voice, does not support the data. The drawbacks of first generation: poor voice quality, poor battery life, no security, limited capacity. Another drawbacks of first generation is it allows only voice calls in one country. These are the first generation. Next, second generation, it is introduced in 1992. The example of second generation is GSM. It stands for GSM, Global System for Mobile Communication. The upload of second generation in between 88 to 915 megahertz, downloads 925 to 960 megahertz. 920 megahertz. Even though we can consider the two versions of GSM, the first one is 900 spectrum, second one is 1800 spectrum. 1800 spectrum. The bandwidth of second generation 200 kilohertz. It can be considered the modulation is GMSK, guys, and minimum SIP keying. The multiple access we can consider to the second generation, both FDMA as well as TDMA technology. TDMA technology. The data rate of second generation 64 kbps. The main features of second generation is it enables such as text message as well as multi MMS and MMS. The main drawbacks of second generation is these systems are unable to handle complex data such as video calls. Next one is 2.5 generation. Sometimes 2.5 generation is described as second generation cellular technology combined with, like we can consider the GPRS and hedged technology. This stands for GPRS, General Packet Radio Service. Hedged technology, evaluation of data, global system for evaluations. Next, the main features of 2.5 generation, it supports the phone calls, web browsing, the data speed of 2.5 generation in between 64 to 1.144 kbps, 144 kbps. Next, third generation, it is introduced in 2000, developed by the UMTS. This stands for UMTS, Universal Mobile Telecommunication Systems. Universal Mobile Telecommunication System. It supports the upload 1920 to 1980 megahertz. Download it supporting to the 21110 to 2170 megahertz. The bandwidth of third generation, generally we can consider to the 5 megahertz. The modulation is QPSK. The access WCDMA. This stands for WCDMA, wideband code division multiple access. Wideband code division multiple access. And also the supporting to the 3.4 generation like HSDPA, HSUPA, and HSPA. The data rate of third generation in between 0.3 to 30 Mbps. 30 Mbps. The main applications of third generation we can consider to the voice, data, and video call. Like it's supporting to the VoIP, voice over internet protocols. Voice over internet protocols. The main features of third generation, it is web-based application and audio and video call can be supported, and also 3D game supported. Next, TV and mobile TV and phone calls can be supported at the third generation. So it takes 11 seconds to 1.5 minutes time to download the 3 minutes MP3 songs. The drawbacks of third generation, expensive 3G phones, large cell phones, high bandwidth requirement. High bandwidth requirement. This is the third generation and 3.5 generation. Next one is fourth generation LTE. Fourth generation. It is introduced in 2010. The upload of fourth generation 2500 to 2570 megahertz. Download 26202 to 2690 megahertz. The bandwidth of fourth generation 1.5 to 20 megahertz. The modulation of fourth generation generally considered to the QPSK, QAM, and 64 QAM. The axis of multiple axis of fourth generation generally we can consider to the OFDMA. This stands for OFDMA, orthogonal frequency division multiple axis. Multiple axis. Here the fourth generation can be supporting two. One is the LTE and second one is the present days we are using to the Vivo LTE. LTE, this stands for LTE, long-term evaluation. VoLTE, voice over long-term evaluation. The main applications of fourth generation, like it can be constrained to the voice, data, video call, digital video, broadcasting, and video chat, high definition TVs, and mobile TVs. Mobile TVs. Next, the main advantage of 4G, we can consider to the like a magic. This stands for magic. M is the mobile multimedia. A is the anytime, anywhere. G is the global mobility support. I is the integrated wireless communication. C is the customized personal service. And also the main features of fourth generation, then comparing to the first, second, and third, it's supporting to the high quality of service and high security and high capacity. The drawbacks of fourth generation, it needs complicated hardware. It needs complicated hardware. The comparison of third and fourth generation, especially in data, the third generation it can be considering 3.1 Mbps, but fourth generation it can be considering to the 100 Mbps. Internet, third generation can be using broadband, fourth generation using to the ultra broadband. The bandwidth of third generation 5 to 20 megahertz. The fourth generation it can be using to the 100 megahertz. The frequency of third generation 1.6 to 2 gigahertz. Fourth generation frequency range from 2 to 8 gigahertz. 2 to 8 gigahertz. Next, upcoming technology in India. Developed countries also, developed countries nowadays in like US, UK, China, Norway, and Finland, already the fifth generation is started. Fifth generation is started. Basically, the fifth generation in between from 2010 to 2020. The spectrum of fifth generation is 3 to 300 gigahertz. The bandwidth you can consider to the 0.25 to 1 gigahertz. 1 gigahertz. The data rate up to we can consider to the 20 Gbps. 20 Gbps. Spectral efficiency 30 bps per hertz. The mobility of fifth generation up to 500 kilometers per hour. And the main advantage of fifth generation, it can be supporting to the www. We know only World Wide Web, but fifth generation we can consider to the another W. The another W like wireless World Wide Web. Wireless World Wide Web. The main applications of fifth generation, it support the voice, data, video call, digital video call, broadcasting, video chat, VR or AR, 3600 videos, UHD videos, ultra high definition videos, V2X, Internet of Things, and smart cities, and also can be applications of fifth generation, factories, home, telemedicine, and wearable devices. The main features of fifth generation, it is completely wireless communication with almost no limitations. No limitations. The main features of fifth generation, it support the multimedia newspapers, high definition quality, large font message. The comparison of fourth and fifth generation, especially in circuit switching, data rate, and technology. The circuit switching of fourth generation, it can be considered to both circuit and packets, even though the fifth generations also can be supporting to the circuit and packet switches. Next, the data rate of fourth generation up to we can consider to the 20 Mbps, but fifth generation it can be supporting to the up to 1 Gbps. 1 Gbps. The technology of fourth generation, It combination of broadband like local area network, wide area network, and personal area network. Even though the fifth generation also can be supporting to the LAN, WAN, and PAN. Next one is sixth generation. Sixth generation already the China and Norway countries the research work is started. That sixth generation. The spectrum, the sixth generation of spectrum, very broad frequency, that is 73 gigahertz, 140 gigahertz, and 1 to 10 terahertz. The bandwidth of sixth generation it's supporting to the up to 3 terahertz. The data rate greater than 1 Tbps. Greater than 1 Tbps. The spectral efficiency of sixth generation it's supporting to the 100 bps per hertz. The mobility of sixth generation up to 1000 kilometers per hour. And U and C plan, like U it can be supporting less than 0.1 milliseconds, C it can be supporting less than 1 milliseconds. The main applications of sixth generation, even though it support the voice, data, video call, digital video broadcasting, and video chat, high definition TVs, three-dimensional integrated communications, next full sensor digital sensing and relative, full automated driving, industrial internet, and internet of bio nano things. Full automated driving means now the coming of four wheelers it's supporting to the sixth generation. Without driver it can be using at the sixth generation technology. The main features of sixth generation, it's supporting to the driverless four wheelers. Next one is seventh generation technology. Maybe it is introduced in 2040. First of all, what is seventh generation? Where it started the seventh generation technology? The seventh generation and 7.5 generation, it started at the Norway and some European countries. The main features of seventh generation, but at present we are using to the hand-hub or roaming from the second, third, fourth, and fifth and sixth generation. But seventh generation, it's supporting to the any two different satellite systems are necessary for hand-hub or roaming when mobile users moving from one country to another country. One country to another country. Once again, I will repeat them. Any two different satellite systems are necessary for hand-hub or roaming when mobile use moving from one country to another country. Means we are using to the satellite from one country to another countries. This kind of hand-hub or roaming is using spacing or roaming. Spacing or roaming. And also in seventh generation, space-time block codes are used. What is the importance of space-time block codes used to view the high definition of video broadcasting? What is the use of space-time block codes? To view the high definition of video broadcasting. And also the main features of seventh generation, within a second we can download the 5 films, that is 20 GB files, 20 GB files, and upload the 15 GB files. These are the upcoming of seventh generation. Upcoming of seventh generation. Next one is architectures, fifth generation, network architecture and design. Network architecture and design. So the fifth generation of network architecture and design, like the main content, it's 3GPP local network architecture and functional blocks, reference point, RAN functional split, adding 5G to an existing multi-RAD site, and also RAD types and base station configurations, scaling mobile block hole, and introducing NG-FI 5G architecture options, that is stand-alone and non-stand-alone modes of operation, EPC to NGCN migration scenarios, and interworking. First of all, 3GB, 3GB, 3GPP 5G network architectures. The abbreviation of 3GPP, third generation partnership project, and here like we can consider to the AUSF, AUSF. This stands for AUSF, authentication server function. Next, UDM, unified data management, AMF, 4-axis mobility management function. Next, SMF, session management function, PCF, policy control function, AF, application function, UE, user equipment, RAN, radio access networks, UPF, use plane function, DN, data networks.
Sir, excuse me, sir. We are running out of the time, sir. Please wrap up, sir.
Okay, sir. Right. Yes. Sir, please, sir, 1 minute, sir. Narayan, sir, if in case second slot ledanantu you want, sir, complete chestanu.
Okay, no problem, sir. Please.
Okay, sir. Right. Thank you, sir. Thank you for giving this opportunity.
Please go ahead, sir. Please, sir, I'm not saying it. Please continue, but the speed up.
Okay, sir. Okay, sir. Right. So, 3GB, PP, 5G networks, generally we can consider to the different NG1, NG2 up to we can consider to the NG15. So here the functioning of, especially we are using to the architecture of 3G. In shown NG1 network in between AUSF to UDM, and NG2 in between we can consider to the like RAN and AMF, and NG3 network in between we can consider to the RAN or UPF. NG4 in between we can consider to the SMF, that is session management function, and UPF. NG5 we can consider in between PCF, policy control function, and application function. NG6 we can consider in between UPF and DN, data network. The example of data networks, like we can consider operator service and networks. Next, NG7 refers to the point between SMF and PCF. NG7R is reference point between VPCF and HPCF. NG8 we can consider in between UDM and AMF. NG9 in between we can consider to the 2-core UPF. NG10 the references point between UDM and SMF. NG11 we can consider in between SMF and SMF. NG12 in between AMF and AUSF. This stands for AUSF, authentication server function. NG13 in between consider to the UDM and AUSF, NG14 in between 2 AMF, NG15 in between PCF and AMF. Like AMF, we can consider one is the non-roaming scenario, another one we can consider to the in-roaming scenario. In roaming scenario, the NG15 in between VPCF and AMF, NG16 we can consider in between two SMF, that is, even though we can consider to the roaming between VSMF and HSMF. These are the architecture design of the 3GPP 5G networks. Next, like 5G radio access network functional. So we know UE, RAM, UPF, and DU, and CU. Generally, this stands for CU, centralized unit, DU, distributed unit, and also in between UEF, like using NR air interface, RAM in between UPF using to the NG3 network, UPF to data network we are using to the NG6 networks, NG6 network, like in between distributed unit and centralized unit, we can consider to the next generation FI in between DU and CU. Next, RAM function split and impact on black hole. So, like we are using to the sir, Naran sir.
Please summarize, sir.
అంటే దీనికి చాలా టైం పడుతుంది సార్.
Yeah, that's why it's better to summarize it, sir.
Okay.
Yeah,
okay.
You have many slides, so just you go speed up. That's lighter way. You complete it so within 2 or 3 minutes, sir.
Okay, sir.
Yeah.
So the RAM function speed and impact, and so the radio access networks, like we can consider to the higher level speed and lower level speed. The higher level speed we can consider to the option 1, option 2, option 3, and option 4. Lower level we can consider to the option 5, 6, 7, and 8. So we can consider to the end-to-end maximum latency and capacity requirements. Next, adding 5G to an existing multi-rad macro sites. We can consider that 1GE. Here we can consider the second generation and fourth generation SRM networks. 3G we can consider the MORN networks, that is 100M or 1GE. Fourth generation we can consider the next say 1GE. So from this, adding 5G to an existing multi-rad macros, you can consider the current multi-rad micro cell sites. Typically, we have black hole of 1 Gbps. Next one is adding to the another condition, 5G development to the micro cells very likely to be less than 6 gigahertz spectrum bands. Next, multi-rad micro. So 5G architecture options we can consider to the standard alone, long-term evaluation EPC connected, standard alone NR NGCN connected. So in between ELTE, in between EPC user like SIU, control pan SIC, like UE. Next, standard alone NR NGC connected, in between NGC and 5G NR user NG3 and NG2, like release 15 UE. Next, another non-standard alone or LTE assisted EPC connected. Next, LTE assisted EPC connected. In between ELTE and 5G NR, you can consider to the UE. And this one is ELTE and 5G does not connect into the NGC and both. non-standard alone or LTE assisted. Next, okay, sir. Sir, Narayan, sir.
Yes, sir. Yes, sir. Yes, sir. Thank you,
Okay.
sir. Yeah.
Okay, sir. Sorry, sir.
No problem. Yeah. So,
right. Thank you for
Raman,
giving
sir.
this
Okay.
opportunity, sir.
So, yeah, yes, yes, sir. Thank you, sir, for your presentation. And thank you for all the participants. So now, today, the session is completed. So, again, I request all the participants, please assemble tomorrow. So, okay, with this, I will close the meeting. Thank you.
Thank you, sir.
Yes.